All right, we're going to pick up where we left off yesterday. So on our front sheet, we had an obtuse scalene triangle. It's obtuse because one of the angles is greater than 100. It is scalene because none of the angles are the same and none of the sides are the same. We had an acute scalene triangle because all of the angles are less than 90 degrees. And it is scalene because none of the angles are the same and none of the sides are the same. And the last one that we made it through was a right scalene triangle. It's right because one of the angles is 90 degrees. It doesn't matter what the other two are. As long as you got that one, that's right. His first name is right. His middle name is scalene because there are no congruent angles and there are no congruent sides. So the last thing that we did before we left was to make a 2-inch line segment. So now what we're going to do is we're going to take your protractor, take the open circle that is labeled vertex, put it on the left end point, making sure that your line segment goes through the 0, and we're going to make a 45-degree angle. You're going to connect that tick mark to that vertex. And since I'm doing this one-handed, I'm going to put you down for a moment. All right. So now we've got a 45-degree angle. And on the other side, so remember yesterday we turned our protractor backwards. On the other side, you're going to label, or you're going to put your vertex on that right end point so that your line segment goes through the 0. And on this side, you're also going to make a 45-degree angle. And again, since I'm doing this one-handed, I'm going to put you down for a moment. 45-degree angle. Okay, so now you should have something that looks like this. And because there's an intersection of 2 points, we're going to go ahead and make that a vertex. Now you're going to want to make sure you measure that angle. When you measure your angle, what do you find? If at any point in time you need to pause, you can. And since it is 90 degrees, we're not going to use an arc mark. Remember we talked about arc marks yesterday. We're going to use the universal symbol for 90 degrees. And then you're going to want to make sure you measure your sides. This looks like 1 3/8. Now you're probably saying to yourself, oh, I know this isn't going to be a scalene because 2 of my angles are the same. And if 2 of the angles are the same, lo and behold, this side is 1 3/8 inches. 2 of your angles are the same and 2 of your sides are the same. Okay, so let's name our triangle. Its first name, we've got 2 angles that are acute and 1 that's right. So up here we had 2 angles that are acute and 1 that's right. So what is his first name? His first name is right. Because 1 angle is equal to 90 degrees. All right, so now we need to figure out what his middle name is. If nothing was the same, it was scalene. But we have 2 that are the same. And there's a word that starts with an I that means 2 are the same. And I hope you said isosceles. It is isosceles because two, oh goodness, two angles are congruent, and we have two sides that are congruent. And lots of people like to remember the SOS as same, other, same, for the angles same, other, same. And his last name is Triangle. All right, so now we're going to turn it over on the back. Again, if you need to pause because you haven't made it this far, by all means, please pause. So over on the back, we're going to make a 2.5 inch line segment. A 2.5 inch line segment. And again, I got to put you down. Two and a half inch line segment. The angle on the left so when we say the angle on the left, you're going to take your protractor that you can read correctly, put that dot over on the left end point. We're going to have a 40-degree angle and a 40-degree angle. So both of the angles, the left one and the right one, are going to be 40 degrees. And while you guys are working, I'm going to put you down. You're going to make a 40-degree angle on one side, flip your protractor over, and make the 40-degree angle on the other side. And then don't forget to connect to the right one. Don't forget to connect. All right. Now you've got intersecting lines up here, so that means you need to measure. Make sure you're using your protractor. I know some of you are to the point where you can cheat a little and use the math, which is great. And when I say that, what we're really saying is, so far, all the triangles have equaled a specific number of degrees, and so since we know two of them, we can figure out what the third is. Can you guys see how far that is from the 0 and where it stops? That is a 100-degree angle. So will this be a scalene triangle? We have two that are the same. Are you thinking about the name? And then we want to make sure that we measure. Definitely want to measure. That looks like 1 5/8 because it's a little more than half but less than 3/4, so 1 5/8. And this side over here, well, I'll be darned, 1 5/8. We have two angles that are the same and two sides that are the same. All right, so now we need to figure out what his name is. We have two acute angles and one obtuse angle. So his first name is obtuse because one angle, that's all it takes is one. One angle is greater than 90 degrees. And again, if you don't want to write the symbol for greater than, you can go ahead and spell it out. We have two sides that are the same and two angles that are the same. So his middle name is isosceles. His last name is Triangle because that's the family he belongs in. He is isosceles because we have two congruent angles and we have two congruent sides. Okay, next you need a 2-inch base. Oops. A 2-inch line segment. Oops. Okay, I'm going to have to put you down. Oops. Okay, on the left and on the right, they're going to be 65. So with your protractor, on the left, make sure you lined it up with 0. We're going to do one that's 65, and on the other side, we're going to do one that's 65. Okay, I'm going to set you down while you're working. 65 on the left, and 65 on the right. Be really careful whenever you flip your protractor backwards that you're still able to find the 65 in between the 60 and the 70. And mine crossed right on that little dot up there. That means I put my line too far up. Now you want to make sure you measure that angle. Can you read how much it is? Make sure you measure. If you need to pause the video so that you can have time to look at it, y'all pause. It's okay. So this is a 50-degree angle. Now, just to double check and make sure, we're going to go 65 plus 65. That's 130. And 180 minus 130 is 50. Now, if you don't know where I got the 180 from, take a look at 100 plus 40 plus 40. 100 plus 40 plus 40. Oh my goodness, it's 180. Add up your other ones on the other side. All three angles within the triangle all equal 180. And then don't forget to measure your sides. Since two angles are the same, what do you know about two of your sides? Well, if two angles are the same, that means two sides will be the same. And this is looking like 2 3/8. If you don't want to use 2 3/8, you want to use 2 1/4, that's fine. The closer you can get, the better off we're all going to be, because that's what we're doing. We're practicing how to measure. And yay, it's 2 3/8 on that side too. So we have a 65, a 65, and a 50. All of these angles are less than 90 degrees, so all angles are less than 90 degrees. So his first name should be, did you say it out loud? Gosh, I hope y'all said it out loud. His first name is acute. We have two congruent angles. And we have two congruent sides. So his middle name, gosh, I hope you guys said isosceles. Isosceles. And his last name is his family name. This is an acute isosceles triangle. Okay, last one. It's in this great big rectangular section here. You're going to want to go all the way down at the bottom. And I'm going to put right in between the 2 and the 3 on that little fold. Or if you want, you can scoot it over. It doesn't matter. We're going to make a 3-inch, I was going to say 4. If you want to make 4, make a 4. But I'm going to go ahead and go with a 3-inch line segment. If you want to make a 4, you can. You just better get really low down on that paper. Okay, so a 3-inch line segment. The angle on the left will be 60. The angle on the left will be 60. The angle on the right will be 60. Don't forget to connect. You're going to have to overextend those lines so that they touch. Okay, so you have something that looks like this. So we've got 60 degrees here. We have 60 degrees there. And we need to measure. We had intersecting lines up there. So turn your protractor over. Let's get to measuring. What is that? It's 60. Yay! And 60 plus 60 plus 60. That's 3 60s. Does that make 180 degrees? Now, if 3 angles are the same, see, a while ago we had 2 angles that were the same, 2 sides were the same. Now we've got 3 angles that are the same. What do we think about the 3 sides? Well, let's measure. This side is 3 inches. Let's check out this side. So far, so good. Yay, that one's 3 inches. If yours didn't come out to 3 inches, you're going to want to double check and make sure that you measured 60 degrees on both sides. Now, if all 3 of the sides are the same, and it is acute, because they're all little, so it's acute. We have 2 sides that are the same. So it could be isosceles if we wanted to, but we're very fortunate, all 3 of them. We call that equilateral. Equilateral. Acute because all angles are less than 90 degrees. All sides are congruent. And that's where the word equilateral comes from. Equa meaning the same, lateral means your line. So equilateral, those are your sides. And it is a triangle. And all angles are congruent.